Set. Go. Alright, so example 10. What is the force of gravity exerted on the Earth? This is the mass of the Earth. By the Sun. This is the mass of the Sun. The mean distance between the Sun and the Earth is 1.0 times 10 to the 11th meters. And the second question was the force of gravity exerted on the Sun by the Earth. Okay. So, which one feels a greater force? The Sun from the Earth or the Earth from the Sun? What do you think, Richard? We're paying attention, were you? Okay. Which one experiences the greater force? The Sun from the Earth or the Earth from the Sun? What do you guys think?
Earth from the Sun.
Earth from the Sun. Why, Sergio? Because the Sun's bigger. Kevin, why? Sounds like a viable option, doesn't it? Okay. What's Newton's law of universal gravitation? Anybody remember? F equals G. Big G, not little g. Okay. Mass times mass over r squared. Okay. So, that is Newton's law of universal gravitation. F equals G, big M, little m over r squared. Now the big M and the little m are what? The Earth and the Sun. The big M stands for the Sun, the bigger mass, right? The little m stands for the Earth, the smaller m. Now some of you are probably wondering, how do we know the mass of the Sun and how do we know the mass of the Earth? There is not a scale we can put them on. Yes, Google can tell you now, but how does Google know?
Because Google knows everything.
Google knows everything. So Google just knows how to mass planets, right?
Yes.
All right. So some of you are probably thinking that, and don't worry, I will explain that to you later on as well. All right. There's a really cool equation that we'll look at later on this unit. All right. So those are, or that's the equation we're going to use. Now, how many equations do you see here? One or two? One. And it contains both the big mass and the little mass, right? So let me ask you again. Which one feels the greater force? The Sun from the Earth or the Earth from the Sun? They feel the same. Thank you, Nikira. They feel the same because there's only one equation. If there's no other reason you remember that, there's only one equation. It has both masses in it, right? Right? They're both on top, too, so it's not like they're in any different spots. Right? They both are in basically the same spot in one equation. You can also think about it this way, Richard. Right? Newton's third law. What does Newton's third law say? Every action has an equal and opposite reaction. So the Sun pulls on the Earth. Guess what the Earth does?
Pulls back.
Pulls back with an equal and opposite amount of force. Okay. So we already answered the second question. What's the force of gravity exerted on the Sun by the Earth? It's equal to what we get for the first question. I just got to figure out what the first question is. And which way do they pull each other? Which way do they pull each other?
Opposite.
Towards each other. Good. This is why it's called a force of? No. A force of? Begins with an A. Some of you are hoping for this on Valentine's Day.
Action.
What is it? Attraction. Good. It's a force of attraction. It brings them together. So, I know I should have told you this on Friday. Maybe I did. But any two objects with mass have attraction. All right? So, when you were at the dance on Saturday night and that girl didn't want to talk to you because she said that she wasn't attracted to you, or that boy didn't want to talk to you because they said they weren't attracted to you, they were lying. Okay? They have mass. You have mass. There's a distance between you. So, there is an attraction there. Well, I don't know if I'd go that far, Sergio. But even when they lie and say they're not attracted to you, it's what it is. It's a lie. Because their mass is attracted to you. All right? Does that make sense? Yep. Yep. Because what the rocket, what you don't see is the rocket is shooting very small gas particles, but a very large amount of them backwards. Because you think about, you have fire, right? With fire, there's smoke, right? Well, the smoke from the fire on the engine, the exhaust from the burning of the fuel, gets propelled backward at extremely high velocities. Okay, does that make sense? It's really a conservation of momentum problem. It's called propulsion. All right. So, any question about this law of attraction? It brings two things together. All right. So, any two objects with mass experience attraction. So, Sergio, there's still hope. Oh, why did I do that? We need that. Okay. Let's write down some things we know. What's the mass of the Earth?
5.
0.9736 times 10 to the 24th. Then I can't say 24. When I move the screen, you will. All right. I got that math not from Google, from page 173 in your book. It's also on the back cover of your book. Okay. The mass of the sun, which I write as the big M, is 1.9891 times 10 to the 30th kilograms. Oh, almost fell over. The distance between them, the radius is 1.5 times 10 to the 11th meters. And big G is, you remember? Henry Cavendish told us? 11. Close. Negative 11. Okay?
Well, I was close.
So I say close. Okay, 6.67 times 10 to the negative 11 power. So that is everything we need to figure out the force of gravity, the force of attraction between the Earth and the Sun. Okay. So we have the Sun. And we have the Earth. Once again, not to scale.
Not too close though, because you're gonna burn the Earth.
All right, not to scale. But there's the Sun and the Earth, right? Which way does the Sun pull on the Earth? To the left or to the right? To the left. This is the force on the Earth from the Sun, right? Which way does the Earth pull on the Sun?
To the right.
To the right, and they are
Equal.
So it's the force on the Sun from the Earth, and these are third law pairs. That's why I have that dotted line right there. Okay, they are a third law pair. They are equal and opposite. Okay, they're probably saying, well, if they're equal and opposite, why does the Earth move? Okay, it's the same reason when you drop your pencil off your table, why the pencil moves. Okay, who's bigger, the Earth or your pencil? The Earth, right? Your pencil has such a small mass compared to the Earth that when you push your pencil off the table, right, that force it feels accelerates the pencil at a very high rate. All right, because the pencil's got a very small mass. The Earth has a very big mass, right? It experiences the same force. So it gets accelerated at much smaller rates. Almost zero, because the mass is so big. All goes back to Newton's second law. All right? So, let's do this problem. So, F equals 6.67 times 10 to the negative 11th. Oh, I got some other stuff there. Times, you can just put the multiplication, you don't need a parenthesis. 24th times 1.9891 times 10 to the 30th, all divided by the radius squared. Okay. Now you're probably thinking, how do I put that in my calculator? Right? Instead of times 10 to the, what should you use? What button should you use? E. You get E by hitting second comma. Alright, so you plug this in your calculator, and it's really important down here in the bottom that you use the E. 6.67 E negative 11 times 5.9736 E 24 times 1.9891 E 30, all over, and this is where it's important that you put the E, 1.5 E 11, and I put that in parentheses and squared. So you punch it in like that, then you'll get the correct answer.
Is E 10?
E means times 10 to the. You hit second comma. So hit the blue button, and then there's a comma right above the 7.
Oh.
It'll give you a little E. And that little E means times 10 to the. But if you do this, Gunas, and you put it like this, the calculator sees this as 1, 2 numbers.
Oh.
Okay? If you do this, the calculator sees it as 1 number, which makes the vision a lot better. Alright, so what do we get?
11.
No, it's not 11.
35.2.
What is it?
35.2
35.2, that's not, oh, times 10, okay.
times 10, 21.
35.2 times 10 to the 21st.
Yeah.
Anybody else get that? Can't remember off the top of my head. I'll check just to make sure. Not that I doubt you go now, but I know there's a lot of E's and such. Oh, I got 3.5 times 10 to the 32nd.
It's
I got. Okay, want to try it again? Make sure. Okay, try it again. Make sure. Anybody else get that? Don't forget when you square this, that means 11. That means
22.
yeah. 11 plus 30 plus 24 minus 22. Ah, you're right, Gunas. I made a mistake. Gunas is right. Why do I doubt you? My goodness. Forgot a 1. Yep, you're right, Gunas. See, guys, even the teacher makes mistakes with this stuff. Okay, good. Thank you. So, Guna said that she checked it by doing this. Remember when you multiply exponents, what are you supposed to do? Add them. And when you divide exponents, what are you supposed to do? Subtract them. Plus 24, which is 13. Plus 30, which is 43, right? Right? So 43 minus 11 twice is 21, right? This is close to 21 because when we actually multiply 6 times 5 times 1 divide by 1.5, you actually get 35. So 22 is close to 21 because the calculator moved that decimal for me. So that's a good way to check. If adding and subtracting the exponents is close to the exponent you have here, then you probably plugged in the calculator right. The error I made is I did this, which is why I had 32 instead of 22, because I subtracted 1 instead of 10 instead of 11. All right, does that make sense? Okay. All right, any questions about that? So that's a good way to check yourself. Add and subtract the exponents. It's close to this one, then you probably punched in your calculator correctly. All right, let's try part B. So B says, oh, I forgot. What was the force of gravity exerted on the sun by the earth? It's the exact same number, right? I know we already talked about it, but equal and opposite forces. All right, B. The force of gravity between the sun and Mercury. Mercury has a mass of 3.3 times 10 to the 23rd kilograms. Is 7.357 times 10 to the 30th newtons. What is the radius of Mercury's orbit? Okay. So, for this one, we still know the mass of the sun, 1 times 10 to the 30th. We know the mass of Mercury is 3.3 times 10 to the 23rd, right? Right, guys? Right? We know big G is 6.67 times 10 to the negative 11th. And we know the force is 7.357 times 10 to the 30th newtons. So, there's our list of everything we know. What do we have to find?
Radius.
Radius. So here we're looking for R. So what does R equal? So, I would like you guys to take this list, and I would like you to try to find what R equals.